This video covers solving a compound linear inequality in interval notation. So what we want to do here is we want to solve the compound inequality and we want to write the solution in interval notation. And if there's no solution, our solution would be the empty set. What I always recommend is down here, I always sketch a number line. It doesn't have to be a pretty number line, but it makes it easier to visualize the interval notation. So let's get started. I have 4x plus 3 is less than or equal to 7. Or 2x plus 2 is greater than negative 10. Or means union. So I'm looking for everything that makes the equation on the left a true statement together with everything that makes the equation on the right a true statement. So let's solve the equation on the left first. I subtract 3 from both sides. 4x is less than or equal to 4. Divide both sides by 4. X is less than or equal to 1. So I plot my 1 with a closed dot because it's less than or equal to, and shade to the left because it's less than. Let's change colors. Next, I'm going to solve this equation on the right here. I'm going to subtract 2. 2x is greater than negative 12. I divide both sides by 2. So x is greater than negative 6. So I go to negative 6. I put an open circle because it's just greater than, and I shade to the right. Notice how I've covered everything, right? My solution is going to be all the blue together with all the orange. So my solution is actually the entire number line, which we would write from negative infinity to positive infinity. And if you aren't confident on interval notation, please go back and watch the video covering the topic of set builder and interval notation. But let's keep moving forward. I have 3x plus 4 is less than or equal to negative 8, and 4x minus 4 is less than or equal to 8. And means intersection. I only want x values that are true for the equation on the left and on the right. And sketching this makes life so easy. I really, really think so. So again, here's your number line. For the equation on the left, I subtract 4 from both sides. I have 3x is less than or equal to negative 12. I divide both sides by 3 and get x is less than or equal to negative 4. So it's a closed dot because it's less than or equal to, and I shade to the left because it's less than. For this equation on the right, we'll do that in orange. I'm going to add 4 to both sides. 4x is less than or equal to 12. Divide both sides by 4. X is less than or equal to 3. So I go to 3. 3 is part of my solution, and I shade it to the left. Now what I'm looking for is what's both blue and orange. So let's highlight that in green. It's going to be this closed dot and everything to the left. So in interval notation, I have from negative infinity all the way to negative 4, and that gets a bracket instead of a parenthesis because our endpoint's included. Next, I have 3y minus 12 is greater than or equal to 13, or 2y minus 1 is less than or equal to 9. So or means I'm looking for the union, right? Let's go ahead and switch back to blue and solve this equation on the left. I'm going to add 2 to both sides. 3y is greater than or equal to 15. I divide both sides by 3. Y is greater than or equal to 5. So here's 5, closed dot, shading to the right because it's greater than. Switching to orange, I've got 2y minus 1 is less than 9. A negative 9. I add 1 to both sides. 2y is less than negative 8. I divide both sides by 2. Y is less than negative 4. So I go to negative 4. It's an open dot, and I shade everything to the left because it's less than. So my solution is all of the orange and all of the blue. So in interval notation, we're going to write this as from negative infinity all the way to negative 4, and -4 gets a parenthesis because it's not included. Then we've got this jump right here. So we're going to use a union symbol, union with 5, which is included, so it gets a bracket, all the way to positive infinity, which gets a parentheses because negative infinity and positive infinity always get parentheses. So our last example, we've got 4x minus 3 is less than or equal to -11, and 3x minus 5 is greater than 7. So I'm going to solve this equation on the left first, and it's and. So again, we're looking for intersection. We're looking where we're going to see both blue and orange. So I add 3 to both sides. 4x is less than or equal to -8. I divide both sides by 4. X is less than or equal to -2. So I go to -2, which is an endpoint that's included, and I shade everything to the left because it's less than. Now for the equation on the right, I'm going to add 5 to both sides. 3x is greater than 12. I divide both sides by 3. X is greater than 4. So 4 is not included, it's an open dot. And I shade everything to right. Now for and, I'm looking for intersection. Is there any intersection here? Do we see anything that's both orange and blue other than the symbol up here? No. So if there's no solution, that means our solution is going to be the null set, the empty set, this symbol right here.